Hello, in this demo I'm going to actually show you some C# exception handling as outlined in the PowerPoint slides. So what I have is I've set up a little program and it's supposed to parse some customer records. I've got a run function that calls print balances, and print balances calls process records, and process records just throws an exception. Because I haven't actually written it yet. So there's throw new not implemented exception. You forgot to write process record. I could also just say throw new exception. That would work too. Not implemented exception is a specific type of exception designed for this specific case. Now let's just run it and see what it does. And you can see that, whoops, we can see that it, well, it certainly, no. Okay, so we hit our breakpoint there, and now we're done, and it crashed. If we ran this thing on the command line, I'm going to go to start without debugging here. You can see it says it blew up on in program.cs on line 15. Like, that's not super useful, but it did actually give us a stack trace. So it said that it blew up at process record, which was called by print balances, which was called by run, which is called by main. So that's actually kind of useful. All right, so watch what happens now. What if we didn't want our program to just straight up crash? What if we wanted to at least maybe have a crash reporter or something like that? How would we do that? Well, up here in main, let's put a try catch block way back up at the top, and let's watch the stack unwind. Let's put a try catch block. And I'll just put in here so I've got this exception. Let me print out the message of that exception. And what else does that exception have in it? It's got a stack trace. And then now that I've printed out the exception, maybe I've logged it or something like that, you know, maybe I would, maybe I've got a crash reporter. Program that I could call or something, or I send a text message or something like that, make an entry in a database that somebody's got to handle. So let's run this and see what it does. And I'm also going to put a breakpoint here so you can see that even though this throw and this catch are several function calls apart, watch what happens when, okay, there's our throw. Now what happens when we throw the exception? Remember, the stack unwinds, and the runtime is going to try to find a catch block that can handle this exception. So it's got to unwind the stack all the way back up to main, and now it found a catch block, and now it can print out the stack trace, the message, and the crash reporter. So what do we have on our console here? So you can see now we've got our stack trace that says it blew up in process record from print balances from run to main. That's useful. And then there's the final error message. You forgot to write process record, and then we're going to bring up the crash reporter. You know, in our little in a real world, we'd have some sort of way of reporting that error occurred. So there's an example of throw to raise an error, and now we've got try catch as a way of responding to those errors and handling those ourselves. So let's take a look now at catching an exception and then rethrowing the exception. So we've got our run function, and it calls print balances, and then let's say the print balances function here has to open a text file. Now I've actually written a little text file, but without giving too much away here, there's text IO is really easy in C#. I'm going to make an array of strings here called records, and then what I'm going to do is say file dot read all lines, and then I have to give it the name of the file, records.text, and file is giving me an error right now because I haven't included system.io. So let's see if that's one of the fixes here, using system.io. So let me say yes. So now we've imported system.io. And what this does is it'll open the file and read every line out of the file and put it into this array of strings. I mean, it's like, what could be easier? File.io in C# is awesome. But what happens if this file's already open? What happens if the file doesn't exist? Well, what happens if the file's corrupt? Well, let's put a try catch around this. Try catch. And we could catch different types of exceptions here. We could say, you know, file not found, file, maybe the file's already opened or something. Well, let's say, let's write out an error message here. Console, no wait, throw, yeah, we could write an error message here. Console, whoops, CW, unable to load records. All right. You know, maybe I even put in the file name from records.txt. Like, the more information you can give, the better. All right, so we're going to log that error message, and then let's throw a new exception. Back up the chain of command. Now, what's the cardinal sin that I'm committing here? So this thing blew up and gave me an exception EX. I don't want to just throw that away. I want that to be preserved. So let's supply that as the second parameter. So I'm making a new exception that wraps the old exception. So I'm kind of nesting the exceptions, kind of like a Russian doll kind of thing. So this print balances is now going to potentially blow up. And when it does, it'll log out an error message, and then it'll throw, it will throw that exception. So, oops, what did I just do? Oh, it must be 2 o'clock because my MySQL installer just updated. Okay, all right. So now let me make sure that this thing does in fact crash. And if I open that bin debug, here's the text file that's got the records in it. Let's run this and see what it does. I'll put an error message, or I'll put a breakpoint there. I'll run this. And what happened? Let's put a breakpoint there. Maybe I am allowed to open it twice. Okay, so is this going to work? Oh, it actually completed normally. All right, so apparently you can, because it opens it read only. Read all lines. Okay, so what if the file weren't there? Like, what if I just have the name of the file wrong? There's no file called records2. Let's run that. Okay, so it's going to try to it's going to try to read everything out of records2.txt, which doesn't exist, which is going to throw an exception. Boom. Okay, so now it throws the exception, unable to load records from records.txt. But we're not done yet. We need to notify, like, the next guy up the chain of command. So let's make a new exception that wraps the old exception. And now we'll throw it up to the top and print it out. So what is it going to say now when we go to our console? Forgot to write process record. Oh, that's our old. Let's run this to the console here. Start without debugging. Debug. Start without debugging. Okay, and then what does it say here? Unable to load records from records.txt at exception demo. Okay, and then now we have our stack trace, and now we have the crash reporter. So now we didn't lose that information from the first exception. That's our that was what we wrote to the console there. But let me show you how this is actually working now. So now you get back to the top level, and exception E here may actually be a wrapper around several other functions that were kind of packaged up as the stack unwound. So how do we get all that information out? And if we let me just put in just a little divider here so we can see what's going on. Oh, you know what? We know this is working here. Let me comment out the stack trace. So this exception here, E. Let's look at what's in E. Notice it has an inner exception. This is the exception that it's wrapped around. So what we can do is we can say while well, let's make an exception e here. Let's see. E dot inner exception not equal to null. Okay, sorry about that. So let's do while the exception is not null. Let's write out the exception's message, e dot message, and then let's go to the inner exception. We'll say now e is equal to e dot inner exception, and we'll just go. What we're doing is printing out the outer layer, peeling the outer layer off, then printing out the message, peeling off the exception, printing out the message, peeling off the exception. We're kind of like, pulling the Russian doll apart. So let's run this and see what we get on the command line. Start without debugging, and now you'll see this thing kind of blew up, and I know we got a long error message there because this big project path, but unable to load records from records.txt, and then we unwrapped that and looked at its inner exception, and it says could not find file. Now that's a useful error message, right? So now we knew kind of what it was doing when it blew up. So there's an example of how you can catch an exception, wrap a new exception around it, and then throw the new exception back up to the top of the command. So what you're doing is you're stapling an error report to an error report and giving the error report to your boss, who staples his error report to it and gives it to his boss. And then at the very top level, you can unroll all of this stuff. So there's an example of catching an exception, wrapping a new exception around it, and throwing that. And then now you're getting a very useful stack trace, or a very useful hierarchy of information, or set of information about that error message here. So now let's talk about, let's go look at multiple catch blocks. Let's go back to this guy. We could add another catch block here, file not found exception. And let's call it like FNF, or file not found, right? And then we could also put so now you can see that we have now we've got two try catch blocks here, or a try with two catch blocks. And notice I have the more specific type first, and let me put in here unable to find file records.txt. So the error message is a little bit different. So there's an example of I can have a try block with two catch blocks. And the reason you might want to do this is because depending on your situation, you may be able to handle, if you know it's a file not found exception, maybe you do something differently than if it was just a regular generic exception or some other specific type of exception. So there's an example of try catch catch, or multiple catch blocks. All right, so now let's look at a finally statement here, and finally. Okay, so let's go back to print balances here, where we open up file.readAllLines. Let's add a finally statement in here, and the finallys go after the catch block. So it's try catch finally. And I'm just going to put in a CW tab in the finally block. Okay, so now let's put I just want to show you what happens. Let's put a breakpoint here. I'm going to put a breakpoint here. I'm just going to put a lot of breakpoints in here so we can watch the path through this, so we can see that the finally block gets run even though an exception happens here. Let's run this. Okay, so there's our read all lines. This is going to throw an exception, so watch what it does. Okay, so now we've caught the exception, we're handling it, and we throw it, but before we go up the stack, look, we look for the finally block and we close, and then we're just that's where we could close any resources that we'd opened. File.readAllLines doesn't open any resources, but you can see that the finally block actually did get run. So we caught the exception, and then we hit the finally block, and now the rethrow happens, and now we can handle that at the top level. So there's now we're going to unwind our error messages. Okay, so now lastly, let's just look at using. So here's an example. I've made a silly little class called resource. It does nothing. But it implements the iDisposable interface, which means it provides a dispose function. So the idea is, let me add a public constructor here. I'll put hogging a resource. There we go. So now, in my run function here, instead of doing this, let me resource r equals new resource. And why does it not like that? Okay, hang on. Okay, I just spelled resource wrong. That's all. So now, if I run this thing, and maybe I forgot to call its dispose function, let's just watch what happens when we run this thing on the command line here. Why is it not? Must return a value. Public. Spelled resource wrong. How did I do that? No, not that. This. Debug. Start without debugging. Okay, so that thing I created, it says hogging a resource, right? But did I ever let go of that resource? No, I didn't. So how do I make sure that I don't forget to release that resource? Well, I could remember, if I were, where's our resource? What I could remember to do something like resource r equals, and then I could try to remember my try finally, and then in here I would call r.dispose. But what if I forgot to call, what if I forgot to do that? And whoops, debug, start without debugging. So now we should see, okay, freeing up a resource. So when we called our dispose function, we freed up the resource. But what if we forgot to do that? So if you're doing anything that you think might use a resource, what I like to do is I just like to use the IntelliSense. See, does the thing have a dispose method? And if it does, then you wrap the thing in a using statement. And nowhere in here do you see me calling the dispose function, but remember, using is just an alias for try finally, try finally, and then inside the finally calling the dispose function. So now watch me run this and see what it does. Run debug, start without debugging, hogging a resource, doing something with the resource, and then freeing up the resource. Boy, I cannot spell today. That's for sure. So you can see there, resource. So you can see that is what the purpose of doing something with the resource. That is the purpose of the using statement. This is a syntactic equivalent of try finally, where inside of the finally you call the dispose function for this thing, the thing that you have supplied in the using statement. And let's just run that on the command line one more time so I can see the correct spelling. Hogging a resource, doing something with the resource, freeing up the resource, right? So that is the purpose of using. It expands to try finally with dispose called inside of the finally, and it is there so that resources get freed up when you're done using an object. Okay, and then lastly, I would say, never do something like this. Try catch exception where you don't do anything, right? Because if this thing produces an exception, let's say it throws an exception, it gets in here, it gets caught here, and it doesn't do anything. Like, what's the point? Like, why did you do that? All you did was bury the error message that somebody probably needed to know about. So don't ever just do try, some code that could throw an exception and then catch it. This is just lazy. It makes no sense, right? So this is not a way to do array bounds checking or something like that. So there's kind of an overview of throw and try catch, try with multiple catch blocks, try finally, and using, which expands to try finally and then calls the dispose of the thing you're using. So there's a little demo on C# exception handling. I hope you found it useful.